Okay, so let's start our lecture 3. You tried your questions or not? Right. Well, let's start this class from a fresh topic. Although I have a question for you guys. In the meanwhile, you will think about it. I'm giving you a set which is collection of 2 by 2 matrices. Say x belongs to some real number. Getting? You tell me if this composition is multiplication of matrices, then it is a group or not. So that is task for you guys. You just check it out how it's gonna work. Why I have picked this question? Because this is a good question actually. Here you can actually learn about how to find identity, how to find inverse, because if you look at this collection of matrices, means this S is a collection like this, or you can say means here if I talk about this matrix, obviously the determinant of this matrix is 0. Then you will recall general linear group. There what I stated is that with respect to multiplication, if we want to form a group, then this determinant must be non-zero. But here this is not a general collection, this is very specific collection. So for this group, if I want to check whether it is a group or not, we need to check number first, closure, or you can say this multiplication of matrices is a binary operation or not. So if I multiply any two arbitrary matrices, what I am going to get is xy plus xy, that is 2xy, 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 2xy. Is that clear? So this is again some element like z, 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 z. It will be in the set S or not. Multiplication of two real numbers is again a real number. So this is an element of your set S. So what you can conclude here is S comma dot is an algebraic structure. That clear? Now, second, what do you wish to have? Associativity. So multiplication of matrices follows associativity, right? Number third, for identity axiom, what is the definition? We need to show the existence of some element in your set S such that on multiplying that element, that matrix with any matrix of this set, we get that matrix itself. So let there is some element E is equal to A belongs to S such that it works as an identity element. If it is an identity element, then for any arbitrary element of set S, it must give A composition, E must give A only. Is that clear? So multiply AX plus AX, 2AX, 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 2AX. It goes to X, 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 X. This implies 2AX equals X. This implies A equals 1 by 2 provided that x is 0. Otherwise, x upon x you cannot write here. So A is 1 by 2. That means we have proved yes, there exists an element E is equal to 1 by 2, 1 by 2, 1 by 2 belongs to S such that if you take operation with this E, you get that element itself again. So this is the identity element of the structure S comma dot with respect to the composition multiplication of matrices. So what it shows dear, if I talk about multiplication of matrices and I have some specific set, then always you cannot say like that the identity matrix is the identity element. See, this is not an identity matrix. Getting? So this example is a very nice example to show how you check the identity axiom. Okay. In the same fashion, we can talk about inverse axiom. Let's say for inverse, what you wish to have dear? For each A belongs to S, there must exist some element in S such that A composition B must be identity. So let's say I have this arbitrary element as this. I want to calculate what is that element B. Identity we already have in the third step. This implies 2bx equals to 1 by 2, or this implies b equals 1 by 4x or not. So you can say if for each element of S, any arbitrary element, we have an existence of some element B which is again in S. Why? All these entries are same. Also X is non-zero. So well defined. This means S possesses inverse of each element with respect to the composition as multiplication of matrices. Is it clear to you all? So this is a very nice example of a group where you learn how to conclude something from the identity axiom, how to conclude something from the inverse axiom. Identity matrix doesn't mean it is identity element for each group with respect to multiplication of matrices and all. Clear है? So this is a good example. अरे यार homework देना था, पूरा करा दिया. चल, anyways. So let's start today's topic. Order. ठीक है? So order of a group. Order of a group means number of elements in that group G star, or you can say cardinality of G. So if it is some finite number, we say group is of finite order. If it is not a finite number, we say group is of infinite order. Let's say if I say Sn with respect to composition of function, then what is the order of this group is n factorial. Clear? If I say Z, this is of infinite order. R, C, these are of infinite order elements. Getting? You can say Zm with respect to addition modulo M. What is the order is? M. Is that clear? With respect to multiplication, ZP, multiplication modulo P. The order of this group is P minus 1 because let's say Z5 I talk about. So star 0 I won't take for multiplication. This I already told you. So what is the order of this group as? 5 minus 1, that is 4. कितने एलिमेंट है इसके अंदर? 4. Is that clear? Fine. Let's take some interesting example for order of element ZL and R. Let's say I'm talking about spatial. Abhi if I talk about ZL and R, so how many matrices you can form, dear? N by n with determinant non-zero? Obviously infinitely many. So cardinality will go to infinity. If I fixed, suppose that I say ZLN Z5, okay, so it will be A equals Aij collection of all those n minus n matrices for which entries are coming from Z5 with the determinant obviously non-zero. So if this field, we will discuss it later, it is finite field, then this order ka group is going to be finite. Otherwise, if this set of real numbers is infinite, then obviously ZLNR ka order will be infinite. So how it is concluded? Should we discuss? Okay, it's easy one, no problem. Bachcha wala sawal. See, let's say I have some n by n matrix A11, A12, A13, A1n, A21, A22, A23, A2n, AN1, AN2, AN3, ANN. Okay? Now, I want to know if my entries are coming from Z5. So Z5 is what? 0, 1, 2, 3, 4. These are not integers, these are classes. Remember? Now I want to know how many such matrices can be formed with determinant as non-zero and entries are coming from this set. So let's check for the first row. Dekhna, please be on the board for just 2 minutes. It will be very clear. A11 can have any value from 0, 1, 2, 3, 4. That means A11 has 5 choices. A12 has 5 choices. A13 has 5 choices. 0, 1, 2, 3, 4 में से कुछ भी हो सकता है. In the same fashion, this has 5 choices. So the row 1 has total choices as 5 raised to the power 10. But if each of these entries becomes 0, then determinant of this A will be 0 or not. And in that case, this A will not be anymore in this collection, because in this collection we have matrices with non-zero determinant. So that means in this total cases, I have to remove that one case where all these entries becomes 0. Is that clear? Any doubt? Now I talk about second row. Number of possibilities means how many matrices we can frame such in this form. So A21 can take any entry from this Z5. A22 can take, A23 can take, in the same fashion A2n can take. So this is ultimately 5 raised to the power n, but if this row becomes multiple of this row, then क्या होगा डिटर्मिनेंट का प्रॉपर्टी, this determinant will become 0. So that means that is not possible here. This second row cannot be multiple of first row. So how many multiples of this row can be? R2 can be 0 into R1. R2 can be 1 into R1. R2 can be 2 into R1. 3 into R1. 4 into R1. क्योंकि इतना ही तो choices है मेरे पास. 0, 1, 2, 3, 4. Means in this 5 cases, these two rows will become multiple of each other, and in that case determinant will be 0, so that element will not be inside this GLN Z5. So we have to remove those 5 possibilities. Am I clear to you all? In the same fashion, third row, total choices 5 raised to the power n, but if third row becomes multiple of these two rows, it will become determinant 0. It will not be in this set, but I want element of this set, so I have to remove all those possibilities. So how many possibilities these two rows will have simultaneously? 5 into 5. In the same fashion, I can conclude row n will have the choices 5 raised to the power n minus 5 raised to the power n minus 1. So first row and second row and third row up to n and nth row, how many total choices we will have? 5 raised to the power n minus 1 into 5 raised to the power n minus 5, 5 raised to the power n minus 5 ka square into 5 raised to the power n minus 5 raised to the power. So what is the order of this? Is getting any doubt? Any problem? No. So this is how you can talk about, okay, many of you, if you are confused between ki how I have taken this, so this is just very simple permutation combination. If you are confused, so suppose that n की जगह मैं 2 ले लेता हूं. So 2 by 2 matrices entries are coming from this. If I take 0 0 0, obviously this will not go inside this group क्योंकि इसका डिटर्मिनेंट 0 है. If I take 0 1 2 1, it will go inside because इसका डिटर्मिनेंट नॉन 0 है. n की जगह आप take it 2. So in this fashion, if I keep writing like this element, how many elements we will have? That is the cardinality of this ZL2 Z5 or ZL2 Z2, whatever you wish to have. Is that clear for you guys? Fine. So in this manner, you can discuss. In general, if you want to write exam point cardinality of VLN ZP, it will be p raised to the power n minus 1 number of choices. It means number of possible elements in the first row into second row into third row into the last row. So this is the point you can remember. Somewhere you can use this. The field structure also we will use this. So please try to remember this form. Y1 is subtracted, P is subtracted. This all we have discussed. Is that fine? Sure. Now I'm gonna discuss order of group with order of element. But it is. It's a very important topic for you guys. So this whole lecture was framed over this topic only. Again, what is the peripheral? That is our first task to do for this topic. As far as UPSC, CSE, IFS is concerned, Number first, definition. Knowing the definition, this you have been doing from the childhood only, but clarity. So this whole lecture series is designed to make abstract algebra more clear, more visualized for you guys. Okay. For this, I will try to find order of elements for all those structures we have studied. It is the fun. Na? Now maza will come. Further, there will be some theorems, some 5 theorems we will deal, small theorems only. Okay, I will state those theorems, only the keyword division algo we use here and the definition. By using these, we can prove all those 5 theorems. In any of the book which you follow, you will get all those 5 theorems in a row. No problem. The next is some formula, like let's say order of G. This is represented like this, is N, and A belongs to G some element, and order of A is, let's say, P. Then what you can say about order of some integral power of A? Is it like this? A very important formula. Also, there are some stuffs like order of AB is order of A into order of B. Is it correct? We will be discussing. And in which case this can be order of AB is order of BA. Is this correct? What is the relation between order of A and X, A inverse X, or A inverse X, A, like that? How you can conclude something? What about order of AB inverse? Can I say order of A into order of B inverse, or something else? Discussing orders for A raised to the power B, M1 and M2, like this. This is the whole peripheral of this topic. With experience from my student as well as teaching career, I have designed, I have concluded, if we are sound in these points, then our mind will be stable. We will be much confident कि if okay, I have done sufficiently, and with this information, with this knowledge, I can solve any question. Actually, this I call box technique, which I used to follow as a student as well as a teacher. I have to confine myself in some peripheral, otherwise mind will be always boggling. This is left, this is left, this is left, this may be left. So maybe wala function, this should not be there. We must be very much stable. It feels you better actually. Okay. So we will start from here, here, then here. This is the today's lecture ka pura agenda. Okay. So definition. Write the definition. Let Z, star is a group. A is some element of G. Then A is said to be of order N, where N is some finite integer. You can say non-zero, such that A is said to be of order N if A is composed N times and you got the identity element, where N is the least positive integer. Because suppose that A composing 5 times, it gives you identity. If you compose it 10 times, obviously E raised to a square ho jayega. Again E. it will give obviously identity. So 5, 10, 15, although all those compositions giving identity, but what is the least? 5. So 5 will be order of that element. Getting? So make it a point, least positive integer, finite, if there does not exist such least positive integer in Z plus, then we say A is of infinite order, or you can say order 0. Both of these terminologies are used, so do remember these things. Is that clear to you? Fine. Okay. So let's apply this definition. Let's say I take this set Z6. What are elements there? I want to check what is order of 1. Okay. So to check order of 1, we have to do 1 का composition. मैंने एक बार किया. This is what I represented as 1 square. Means 1 composition 1. 2. 1 cube. I'm not writing 5 again. This you are addition modulo 5. This you understood. This is 3. 4 times composition 4. 5 times composition 5. If I do the composition 6 times, 6 in modulo 6 is 0. That means if I compose 1 at least 6 times, I'm gonna get as 0, and 0 is the identity element of Z6. So what I will say, order of 1 in Z6 is. Similarly, you can check for 2. Let's say 2 composition 2, 4. 2 composition 2, composition 2, 6. And this is gonna be 6 in modulo 6. So we say 2 cube. 2 cube doesn't mean 2 into 2 into. 2 cube means composition of 2 3 times. It is gonna be 0. Similarly, you can have 2 raised to power 6. That means 6 times composition. Again, you will be getting 0. But what is the least positive integer? 3. So order of 2 in Z6 is 3. From the day 1, I'm saying, please be in the habit of saying complete statement. Order of 2 is 3. This doesn't make sense actually. You have to say order of 2 in which group. Is that clear? In the same manner, I can discuss for other example also. Let's say I discuss Z2 cross Z3. So what are the elements? 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Persons who are not getting this, please do the previous lecture. This is just Cartesian product of these two sets. Now let's say I want to check what is the order. What I will do, I will compose this 2 times. So what it will be? 1 addition modulo 1, 1 addition modulo, because this operation is coming from first set and this operation is coming from second set. What I got is 2 in Z2, here 2 in Z3. So 2 in Z2 is 0, 2 in Z3 is 2 only. Okay, now I do 3 times composition. What will happen? 1, 1, 1. ये किस में है बच्चे? Z2 में. 1, 1, 1. ये किस में है? Z3 में. So 3 in Z2, 1, 3 in Z3, 0. Again, this is not identity. This is not identity. That means I will do composition 4 times now. Then 5 times. Then 6 times. So when you do 6 times, you will be saying that here it will be 6 in Z2. Here it will be 6 in Z3. Ultimately, you will be having 0, in Z2, 0 in Z3. Don't confuse here, dear. This is 0 of Z2. This is 0 of Z3. Clear hai? Z3 is addition modulo 3. That is altogether a different composition. And Z2 addition modulo 2 is altogether a different composition. You cannot say these zeros are same. This is the 0 of class Z2. This is a class of Z3. Getting? So this is identity element of Z2 cross Z3. So what you will say? Order of 1, 1 in Z2 cross Z3 is 6. Is that clear to you guys? In the same manner, if you want to have the practice, if you want to have command over such topics, do calculate order of each element. Is that clear? Fine. Ultimately, if you want to calculate order of, suppose that I have Zm cross, this is exam point for you guys. Zm cross Zn, fine, and you want to calculate order of any element. Please do remember this thing. This is just a bachcha wala gyan, but will help you eventually. Let's take some arbitrary element of this, and you want to know what is order of A comma B. Getting? So to get order of A comma B, what you will do? You will compose A comma B 2 times, 3 times, and so on. We'll check where you are going to get identity. And for that least positive integer, that will be the order of this element. But what I am going to do is here, order of A comma B is the LCM of, please remember, just बच्चा वाला है, अभी बताते हैं. Order of A in Zm, order of B in Zn. What I am talking? A is element of Zn, तो A का order कुछ होगा, B का कुछ order होगा, उन दोनों का LCM ले लीजिए, you will get order of A comma B. For example, you want to calculate order of 1, 1. अभी हमने लिया था ना पीछे वाले में, इस Z2 cross Z3 में. Okay. So order of 1, 1 will be nothing but LCM of order of 1 in Z2, order of 1 in Z3. So order of 1 in Z2 is 2, order of 1 in Z3 is 3. So LCM of 2 and 3 is 6. ये तो मिला था. Order of 1, 1 in Z2 cross Z3 is 6. You getting? ये उतना ही आसान है जितना बचपन में पढ़ते थे ना. 1 घंटी 2 घंटे बाद बजती है, दूसरी घंटी 3 घंटे बाद बजती है, तो कितने घंटे बाद मिनिमम वो दोनों एक साथ बजेंगी, तो बजा दिया एलसीएम, है ना. चलो आगे बढ़े. Now let's take some other example. S3, what it was? I, sigma 1, sigma 2, sigma 3, tau 1, tau 2. I want to discuss about order of tau 1. What it was? Order of 1, 2, 3, or you can say order of, ये 1, 2, 3 क्या था? Just a function only where 1 is imaged to 2, 2 to 3, and 3 to 1. Now I want to know what is the order of. For your simplification, just I am going to write, otherwise this is very simple. 1, 2, 3, 1, 2, 3, sorry. 1, 2, 3, 2, 3, 1. Composition means I am going to calculate tau 1 composition, tau 1. So I just want to know 1, 2, 3. 1 का image 2, 2 का 3. 2 का image 3, 3 का 1. Is it identity? No. Identity is what? Where each element is mapped to itself. Now I am going to compose it 3 times. what is gonna do is see 1 का इमेज 2, 2 का 3, 3 का 1, 2 का इमेज 3, 3 का 1, 1 का 2, 3 का इमेज 1, 1 का 2, 2 का 3. This is identity. So what you can say, dear, 3 is the least positive integer such that tau1 composition 3 times you are going to get identity of this S3. So order of tau1 in S3 is 3. Similarly, you can go for order of sigma 1. These all will be of order 2. You just cross check. Ready? Moreover, for this Sn, if f is a permutation of length 5 cycle, then order of f will be 5. If this f is a permutation of length n, then order of this element will be n. Means cycle of length n, when you compose it n times with itself, then it is gonna give you identity element. So if you want to remember, you can remember this thing. But this is for single cycles. You may have some elements like sigma 1 into this. Suppose that you want to calculate order of this thing. Getting my point? Then this will not work. Here we will have a separate formula. But before giving that formula, as I already told you, you people will be provided the PDF of the lectures in which all these formulas will be mentioned. Also, this is very interesting example, bit lengthy formula that I will also discuss in the class. If you have doubt over the PDF, then let me know in the comment box. I will surely discuss about it. Okay. So move कर जाए अब यहीं से. Order of A into B. That is our next topic of discussion. Is that fine? Let's say G is a group. If order of A is m, order of B is n, then what you can say about order of AB? We may have different categories when AB not equal to A, when AB equals to BA. In this case, whether order of AB is order of A into order of B, again question mark, or some extra condition needed here, like M and N must be relative primes. GCD, this is symbol for GCD, like if between two positive integers we have one is the greatest common divisor, then we say those two integers are relative primes. Ready? So M and N का GCD is 1 plus this condition. क्या इस केस में order of AB is gonna be order of A into order of B? What about this? Why we are not able to conclude from here? All this stuff we are going to discuss in the next lecture. For the time being, I'm stopping here. Not the next lecture. Just after the break, we will be discussing about all those stories. So till then, bye bye. Just for 10 minutes break.